analysis. I'm going to talk about what is a specific data request. I'm going to talk about data cleaning again a little bit. I'm going to talk about preparing the data sets and, of course, documentation. So what is a research data request? Typically, an investigator, a clinician, a scientist will come to the group, the statisticians and the data managers with a question. They have a question they want to answer. They have a hypothesis about what the answer will be, and then they have aims for a specific project. And typically what they do is they write up a concept proposal, which is a detailed plan for how the research project will proceed. And that typically includes the aims of the study. So what are their goals? What are they going to try and achieve with this study? What are the specific associated hypotheses of the study? So like you might have multiple aims and you might have multiple hypotheses, what you think is going to happen. So this is really helpful because the statisticians know all about testing hypotheses given the data. The concept proposal will typically include a statistical analysis plan. Although the investigator or the researcher is not always the one that writes the analysis plan themselves, they do so in conjunction with the biostatisticians. Typically, there's a detailed description of the cohort, and we've talked about what a cohort is. It's defining the population or the study population that you want to analyze or you want to include in your data set. And then also on a detailed concept proposal, there's usually a specific list of variables needed and a description of the data needed to conduct this study. So let me show you a quick example. A concept proposal. So you can see that it can be pretty detailed. We have a description of the study that the investigator wants to perform. We also have a list of statistical methods, so a short analysis plan of how they're going to analyze the data. And then below is a list of the variables, the specific variables that they need, the dependent variables and the independent variables. And just some other administrative information about contacts and so forth. So this is like our guidebook. When the data managers start to put together an analysis data set, we use this to figure out, what patients should be included, what variables should be included, what time period they're looking at, what new variables we're going to need to derive. So in this example, you can see that these are some of the things that we've seen in the demonstration data set. Age and gender and CD4 count. The CD4 plus T cell count is the same as our CD4 count. The WHO stage, which we've worked with a little bit. Opportunistic infections, and these are like the diseases that patients get from HIV. And then a few other miscellaneous variables. And then the dependent variable here is the time to treatment initiation. So this particular concept proposal is looking at the characteristics of patients prior to initiating ART. So the changing characteristics, so changing over time, the characteristics of HIV-infected patients who are getting ready to start antiretroviral therapy in East Africa. So this is an actual concept proposal that we've put together the data set for. These results have been presented at one of the international AIDS meetings, and we're in the process of writing up the manuscript. So that's our concept proposal. That's how things begin, preferably. There we go. So how do we go about fulfilling a data request that's embedded in a concept proposal? I mean, the first thing you want to do is to identify and resolve any questions regarding the requirements. So you have to read through the proposal and understand exactly what the investigator wants and understand what the statisticians are going to do with the data, and make sure that you have a good sense of what is required of the analysis data set. You want to determine what the data sources are. I mean, sometimes data is not coming just from one source. The clinician or the investigator may come with some information from the pharmacy or from another sub-study or something, and you have to be able to merge that data with. You have to determine what all your data sources are and what variables are going to be needed. Almost always there are age, what those derived variables are and how you're going to have a good idea about what those visits and observations are that will be included. Think about what am I going to do to these data sets in order to properly prepare them for analysis. You'll need to prepare the actual data set, about how that's done. And then always you need to document documentation everywhere. Okay, so let's back up just a little bit. It's rare that data are collected. SAS is not a very good tool for inputting data, for actually keying in, for a data entry clerk to key in data. It does have capabilities. You can set up some simple interfaces, but it's not as good as OpenMRS for sure, or other SQL packages, or even Access. So data are not collected in SAS. So if at all possible, if you have access to the raw data, you might want to do some processing and cleaning there before you bring it over into SAS. So when you get ready to start data cleaning in the raw data set, the first thing you want to do is back up the original data files. You don't want to, think about smaller settings here. I mean, you're not going to do this with. But there may be little studies going on, collecting things in Access databases around for little sub-studies. So in those situations, when you're going to extract somebody's data, you want to make sure that you back up that original data files before you make any changes whatsoever. You want to go through and look for blank records. A lot of times, folks that don't have a lot of experience with programming, if they set up an Access database, there'll be a lot of blank records in there. entries with not any actual data or real data, or records in there just that were inserted for testing. So you want to eliminate those if possible. You want to locate any duplicate records. Sometimes, I mean, in Access you can, well, if you set it up right, you can't have two. If somebody that there is an identifier or a set of identifiers that uniquely distinguishes every record in the table from every other record in the table. And so typically you might have different records, so you want to identify those and fix that. Numeric variables, identifying outliers, sorting, and Excel are great for this kind of thing because especially if you have a small database, you know, with not too many observations, you can just click on each column and sort that column. I mean, you want to sort the entire row. You can sort it. Then you can just take up and down and look at your minimum and maximum. So if you're, for example, if you sort at height and you find somebody in there who has an adult with a height of 1, you know, that's immediately go back by each column, and I column. It's great for looking at dates. If you know when the study started and when it ended, if you sort by date and you see future dates, or you see dates in 1908, you know, I mean, you know that there's been entry errors there, and you can fix them right there on the spot before you bring the data back. And then for categorical variables, a lot of inexperienced developers will allow entry of upper and lowercase coding for specific variables. They may also allow, they may have FM1 and 2, you know, so they start out for a field like gender, they start out using F and M, and then they switch to 1 and 2 midway through. I mean, so you can, if you sort the data set, if you sorted that column, you could easily identify where the issues are and where the problems are. And so again, you can fix those on site. And it will actually, I mean, this kind of raw data cleaning is actually helpful to the person who's maintaining the database, you know, because it sort of teaches them how to be more consistent in the future, and it also cleans up their data, their raw data for them, so that if they go to generate some frequencies on gender or something, they won't get four values. They'll only get the 2 F and M, because uppercase F and lowercase f are not the same thing in SAS. SAS understands those as 2 separate values. Not true with variable names, but true with values. And then also when you're sorting those columns, you can easily review the missing data. So if you have, you know, if you sort the gender column and you see that there's 5 or 6 people missing gender, I mean, you can say, do you know what, can we enter this? Do you have this? And they can immediately go, yeah, nobody should be missing gender. We know what gender is on everybody. So you can easily go and grab, you know, you can easily go and grab those data. And then you can just say, ask yourself or ask the person for this variable. The other advantage of doing data cleaning like this in the raw data set is that there are occasionally problems with transferring data to SAS, depending on the format, especially things with Excel spreadsheets. There's a lot of quirky things happening with Excel spreadsheets that don't always come out well in SAS. So if you can look at the data in its original format, you can confirm that everything's transferring to SAS correctly. So how do you get the data from the raw database, or even an ASCII file? I like to have a separate SAS program that just does the conversion, that takes the raw data. The reason I do this is because you often make calculations that you might not want to be reading that. So you want to have, I like to have a separate to SAS datasets. And I think Eva talked about this last week. For converting an Access or an Excel data set, you can use tables. There are limits on how many variables or how many observations can be in an Access table. So people tend to make things a little more modular, and they break things up in smaller pieces. And usually those pieces can be recombined in SAS for the analysis, when creating an analysis data set. So you need to merge or append or concatenate these tables as necessary. You need to double check that the merging process worked properly by looking at the number of variables and the number of observations. Here I'm just talking about the number of observations. So you need to look at you need to know what the number of observations were in each of the data sets prior to merge. And you need to anticipate what should be the number of observations in your final merge data set. And we'll look at some examples. And you also need to understand how the number of records is dependent on the overlap among the data sets. So you might have some patients in this data set that aren't in here, which would create a few additional records in the final merge data set. So you need to understand what the relationship is. So let's take a look at an example here. Let's say you have, oh wow. Okay, so this is actually your, the demonstration. I want to keep the ID, the visit date, age, weight, height, BMI, and CD4 from this longitudinal data set. And let's assume that okay. So in this particular example, so it doesn't match exactly with our demonstration data set. In this particular example, there was about 933,000 observations in the original visit data set. So in this data step, where I'm keeping only the patients, only the records for patient ID 1, 2, 3, 4, and 5, I end up with 71 observations in this subsetted data set. So So that means that there are multiple observations. With 71 observations in that data set. So there must be multiple records. And then the 7 variables are the result of simply pulling in patient ID variables. Okay? So then I have another data set where I data set because I'm including patient 4 and 5 from both of these data sets. Okay? Does everybody kind of get a picture in their head of what's going on so far? So when I do that, I'm still extracting the data from the same administration data set. So the original data set has 943,000 observations plus. And this new data set has 46 observations and 5. Okay, now what happens when I merge these two? How many variables? So some say 10, some say 11. Okay. Let's sort of count them. Let's list them. Okay. So will patient ID be in there? Okay. Appointment date. That's 2. Age 3. Weight 4. Height 5. BMI 6. CD4 7. Patient ID. Do I count that one again? No, because I already counted it, right? How about appointment date? No, already counted it, okay? So clinic, hemoglobin, and SaO2. So there'll be 10 variables in that final data set. Can you tell how many observations will be in that final data set? $117. How do you get that? $46 plus 71. Okay. But I'm going to merge these data sets, right? And the two data sets presumably have some observations in common. For patients 4 and 5, you cannot tell. Right, you cannot tell. How could you tell? If you knew something, you could tell how many observations would be in the final data set. And if the patient IDs were different, what would be the final number? Right, just the sum. Okay, that's good. There's something else. If you know something else, you will also would be able to tell how many were in the final data set. For patient what? Right, right. But you wouldn't have to know all of them. So she said if you knew the number of observations per patient ID, then you could calculate the total. But you wouldn't have to know all of them. How many would you have to know? Actually, only 6. Not 4. You wouldn't have to know 4 or 5. Because if you knew 6, then you could just subtract that number from here. Or if you knew 6, all you'd do is add that number. Let's say 6 had 10 observations. All you'd have to do is add that to this number, right? Because there's complete overlap. Because we're not restricting by any other variables. I mean, all observations for number 4 and 5 are in this data set, and they're also all in this data set. So you really would only have to know how many observations there are for number 6 to get the total. And it could be 0, right? It could be that there are no observations for number 6 there. So let's see if we were right about, oh, look at this. No, so when you do the merge, you read 71 observations from the first data set and 46 from the second. And you end up with, yay, 10 variables, like you said, and 83 observations. So based on that, can you tell me how many observations ID 6 has? 10? 12, right. We should test that and see if we're right. Okay. So, I mean, this is the kind of, I mean, we're really breaking this down, but this is the kind of sleuthing you have to do to confirm that your merge works correctly. And this is a very simple one, right? There's no conditional statements. There's no, subsetting out other observations and so forth. I mean, this is really important to get these merges working right, and not overwriting data from one data set to another. So when you're doing this, you want to confirm that the total number of variables in the merged data set is correct, like we just did in an example. And there's actually a specific formula that you can use based on the number of data sets being merged, the number of key fields, and the number of fields in each data set. So in this previous example, we had 7 fields in the first data set. We had 5 fields in the second data set. 5 fields. And we had 2 key fields, patient ID and appointment date. So that's this 2 here. And you multiply that by the total number of data sets being merged, minus 1. Actually, this might not be right. I'm going to have to look at this again. But it works when you have only 2 data sets. I think this, what you subtract by may be dependent on the number of key fields. So we can look at that later, though. If the number of variables is less than what you expect, then and you know that you have other fields that are common to both data sets. And this should be strictly avoided. You do not want to get into a situation where you're overriding one field with another from a different data set. So if I had also kept age here, then this number would be 6, but this number would still be 10. And you want to avoid that situation where you're merging two data sets that have fields in common that are not in the by statement. Okay? The only variables in common that you want between the data sets that you're merging are what's in the by statement. Because SAS will does kind of some strange things depending on how the records align. Okay. So when you're running SAS program, whether you're creating a data set or for research or doing cleanup queries or whatever you're doing, you always want to review the log before you go on and look at the output or before you send out the data set. And you guys actually, I've been impressed. You've been pretty good about reviewing the log, making sure that things ran properly. And some of the, unfortunately, they all popped up at once. Certainly the error messages, they come up in red, and it's pretty obvious that you've got a problem. You can't really continue without it. There are some warning messages, that allow you to continue. The warning and note messages allow you to continue processing, but you may not be getting what you expect you're getting in your data sets. And this is just a list of 5 of the warning messages or notes that you get that really should be attended to before continuing to process your program. Some of them may not actually be causing problems with your code, but they should be corrected because it means there's an error in your code. The error may not be affecting the actual data sets that you're creating, but it is indeed still a problem. And particularly the first one is a serious problem. And that's the note where you get that the merge statement has more than one data set with the repeats of the by values. And what this means is that there are multiple observations per by category in both of the data sets, so it doesn't know how to merge them. So if your by statement only contains patient ID and you've got patient ID listed 3 times in one data set and twice in another, it doesn't know how to link those 3 observations with these 2 from this data set. Okay? So that leads to confusion. When you get this message, what typically is the problem is that you haven't included enough variables in your by statement. That you don't realize that there's multiple observations per patient in this data set and multiple observations per patient in this data set. And whenever that happens, you cannot merge by a single variable. You cannot merge by just patient ID. You have to have some other variable to merge by. Visit date, CD4 date, whatever, a visit number, whatever else is available. But the point is that you cannot merge these 2 because there are multiple records in each of those data sets for the variables named in the by statement. Okay. And when you run the merge, you get strange results, and you should definitely not continue on to the next step or next procedure or anything until you resolve this issue and that error goes away. Then there are two other notes that are very similar, where a variable is a variable with a specific name. It can be any name here. They'll just list the variable that's uninitialized or has never been referenced. And these indicate that the variable is probably not properly defined. And many times it's just a typo where you've misspelled one of your variable names. And it's kind of handy because SAS picks up on that. The next one, where you get a note where character values have been converted to numeric values, and there's a bunch of other blah, blah, blah. This indicates that SAS has automatically converted a character variable to numeric. Because this can lead to unexpected results in SAS, it's best to do this conversion manually with an input function, which converts a numeric variable to, input, I always get confused. Input is character to numeric, and put statement is numeric to character. And then the last one, I don't see as often, where you have multiple links specified for your by variable. So if you get results from the lab database and patient ID is in there, and you also get results from the clinical database and patient ID is in there, if the people designing those data sets didn't communicate before the design was set up, the length of this field may be 10 characters long, and the length of this one may be 15. So you want to be careful about trying to merge those two until you resolve that length problem. Okay, whenever I run a SAS program, and I typically rerun SAS programs multiple times before I get it right. Sometimes I recreate the data sets, a year down the road or what have you. Whenever I run a SAS program, I just go straight to the log and I search for these. I search for these keywords. So I search for, merge statement. I search for uninitialized. I search for referenced. I search for character values. And I search for this multiple links. You don't have to type in the entire thing, but just a snippet from each of these commands will give you will take you to those problems. And sometimes I search for warning messages as well. I always search for error messages first, then warning messages, etc. Because these don't show up in a different color. The warning messages show up in green, I think. The error messages in red, but the notes just show up in black. So if you're like, it's harder to run through the program and easily spot them. So I just search for those automatically. Okay, so what else do you have to do when you're setting up a permanent data set for research purposes? One of the things is you may need to recode the missing values that were used in the raw data files. As I mentioned earlier, sometimes people use nines, fill a field with nines to indicate missing. These should be converted to a blank or a dot in SAS before proceeding, unless there's a special value, unless they have meaning, an additional meaning, unless that 9 means unknown, or that 9 means that the patient refused to answer. But if it's just general missing, then it should be converted to the missing values. A lot of times we have to calculate summary scores, and a simple example is the body mass index, which is based on height and weight. But there's also a lot of studies that use behavioral questionnaires that ask about, pain and depression, and they may have a series of 30 questions that ask about depression, and there are summary scores that can be calculated from those questions. Sometimes there are multiple summary scores. And we don't typically, in our area, we don't typically do all these calculations in the data entry system. We typically do them at the end in SAS. So there's also the steps you need to add for coding those summary scores. Audit 3 is the summary of the alcohol questions. I think there's 4 alcohol questions and there's a couple of audit scores. You want to look at the differences between the dates, such as time from enrollment to ART initiation. This is also a cleanup query, but a lot of times the analysis, they need to have the durations in the system. So this is a good place to calculate those variables and store them in the data set. Any variables that you calculate, any variables that you derive, any new variables that you create, you must label. And you must document in external, just Word, documentation as well. And then the final thing you want to do is attach formats to specific variables. So like marital status or civil status, we had the values are actually 1 to 7. The entered values are 1 to 7, but 1, 2, 3, 4 doesn't mean anything to the statistician. So that's why we create formats for those values and attach those to the data, to those associated variable. So once you have your permanent data sets created from the raw data sets, you can have a separate program that does the data cleaning and generates cleanup queries. So in the cleaning data set, I like to have generate frequencies and means, and sometimes univariate statistics on all the variables. I just look at every single variable in the data set that I got, to make sure that there are no outliers, to make sure that gender doesn't have 4 levels, to check for invalid data. You can also plot the data. Often I'll plot age against weight, especially if I'm looking at kids, to see how much work is going to be needed in cleaning up those weights. For numeric and date fields, you can look at the minimums and the maximums to verify that the values are in the expected ranges. You can do this if you have few observations or there are limited number of responses. You can use proc-freq to look at everything, look at the minimum and the maximum. But if you have, if you're looking at weight and you've got 10,000 observations in the data set, you probably don't want to run a proc frequency on those. So that's where you can use the proc univariate and the proc means that will show you how many are at the lower end and how many are at the upper end, and you can figure out, you can generate some cleanup queries based on what you see in those descriptive statistics. You want to, locate duplicate records and fix those. If you find multiple observations per patient in what's supposed to be a cross-sectional data set, then you've got to eliminate those records. This is redundant. A lot of this is redundant to what you did or could do in the raw data set, but all of it has to be repeated here in SAS. And then you want to compare fields where appropriate, looking at date of birth and age and visit date, confirm that the date of the initial visit, what they have defined as the initial visit, actually precedes the date of the follow-up visits. Okay. Then you want to kind of pick out the important fields, such as summary scores, and verify their values in more detail. you know, I mean, there's going to be a lot of data collected for a research study, and some of it is not important to the analysis. How many phone calls, how many times a person called in to ask about medication. I mean, those kinds of things may not be useful for the analysis. So you don't need to spend your time on those variables. So that's why it's important. That's why it's important to understand the concept proposal, so you know what the specific aims are for a study, and you know what variables are going to be needed for the analysis to address those questions in the aims. So typically you want to merge all the longitudinal data sets together. You may not want to store that as such in the final data set that you prepare for analysis, but you certainly want to do that as part of the cleaning, so that you can verify that there's no missing questionnaires, or that there's no inconsistencies in how variables are formatted. So the variables that are supposed to be in all data sets, like an identifier and a visit number and a visit date, you want to merge those data sets to confirm that the format of those variables is all the same, and the length of those variables, so that if the statistician needs to merge them, that there won't be any questions about inconsistencies. And then you always want to merge the cross-sectional data set, the demographic data set, with the longitudinal data set, with the visits data set, to identify subjects who are in one data set but not the other. And you may also want to get the date of birth into the longitudinal data set so that you can calculate age and other such variables. But this is only a temporary merge, okay? You don't want to send the data set to the statisticians with gender in every field of the longitudinal data set, okay? In every record of the longitudinal data set, okay? This is a temporary merge where you're just merging to make sure that there's agreement between these two data sets, maybe to do some calculations, but when you actually send the data set out, they need to be separate files. And I'll explain more about why that is. Okay, so when you're writing SAS programs, it's really important to save all of your logs and your outputs, especially the final version that you use to create the analysis data sets. And even more especially if those data sets are going to be used for publication. However, if I give a data set to any statistician or investigator, I have the log and the listing and the SAS program frozen, and the data sets that were given, I freeze those, put those into an archived folder and don't ever touch them again. I copy them into that folder, so that if they come back to me 6 months later and say, I want to run some additional analysis on that data set you created, can you add in these, can you do this? Then I can go back to that exact data set. Even if the other data set, even if data is continuing to be collected and the other data set is growing, I still have that data set as it was at that time, okay? And believe me, this happens. I mean, even after publication, they'll come back and want some additional information about that data set. And if you haven't saved the log and you haven't saved the program, then you cannot reproduce the results, and you cannot answer questions about how that data set was created. When you're naming SAS programs, we talked about this earlier, it's important to give them a name that means something, not just to just call them frequencies or study or what have you. And it's also important to name the log and listing files with the same prefix as the original SAS program. So in this example, study X is not study X, it's going to be like bone studies project, or it's going to be something like you know, it'll be specific to a particular study. But then the log and listing should be named the same thing with just the different extension .log and .lst. And SAS automatically attaches the .log and the .lst when you save it through SAS. Only the program that generates the permanent data set should override it. Only the program that generates a permanent SAS data set should override it, should ever override it. You should not have two SAS programs on your hard drive that modify the same permanent SAS data set. Okay? Because this leads to a lot of confusion and a lot of problems. If you have one program that creates a permanent SAS data set, and then another program that modifies that SAS data set and overwrites it, and you come back to recreate this data set 6 months later, and you forget to run that first program, or you run those programs in opposite order, then you're not going to get the right results in that data set. Okay? The other big disadvantage is the other advantage of not letting more than one SAS program override a specific data set is that you always have the date and time associated with the creation of that data set. You always have the correct data associated with that data set. So if you have a data set that lots of other programmers are using, lots of other data managers are using to generate other data sets, and you let them modify this permanent data set, then you're never going to know, no one's going to know if they have the most recent version, you know, if they just look at the date and time. Because if other programs, even a proc sort, will change the date and time associated with that data set. So if you sort a data set and override it, then all the other programmers might think, oh, I have the latest data set because it's from last week. But that may not be the latest data set. That's just when that particular file was updated. But it may not be the actual data set that they want to be working with. Okay? I even take it one step further and say, even within one SAS program, there shouldn't be more than one data step or procedure that modifies that data set. So you don't want to have two data steps that overwrite the same, that create the same SAS data set. I mean, there's no point in that. I mean, if you just can eliminate that first data step or create a temporary data set for that first data set, and then only output the permanent data set in that final data step. But then it gets a little confusing. Well, what if you want that data set sorted in a certain way? Well, then you have to sort it prior to creating that permanent data set. Okay. Does that make sense? Okay. So then you never want to overwrite a permanent data set, like I said, even with a proc sort from any other program. So only one program creates the data set, and no other programs overwrite that permanent data set. So let's go talk a little bit about documentation. As we said earlier, you want to internally document your SAS programs. At a minimum, you need to include a file name, location, purpose, author, date, and revisions. We also had, when we were looking at the program design language, we also had a header that included inputs and outputs. As I said, to include the names of any permanent SAS data sets created by this program, that would be an output. And then all your SAS printouts, if you create a rich text file or just an ASCII file, you want to put meaningful titles on that output. Meaningful titles that include the name of the project, that at minimum include the name of the project, but you may also want to put something else, the treatment interruption analysis data set, like second generation, or this is something about what the subset is or when it was run. But at least, at minimum, the name of the study or the project would be very helpful. And then you can also use the footnote option. And I usually use the footnote option to display the name of the SAS program that created that output. So this, you can have, so in SAS you can have an option statement with a footnote, and then you just put whatever you want in quotes here in the footnote option, and it puts that on every page of your output. And I can tell you this, more than anything, has come in handy because investigators have come back to me months after I've generated an analysis or a list for them. They come back and say, you know that list you put together for me, can you rerun that? Can you redo that? And I'm like, oh my God, I've got 25, 30 projects going at once, and then I'll say, hey, is there a note at the bottom of that page that tells what program generated? And they go, yeah, and it says this, and I can just go right to the folder, right to the program where that generated that particular output. So it's very handy. It's a good habit to get into. Okay, like as you saw with the demonstration data set, when we have formats attached to specific variables, we need to make sure that we include those format value statements somewhere in the documentation. You always want to generate format keys. We talked about that. Make those available. And you want to provide a detailed description of any variables included in the data set that are not found on the form key. These would be all your derived variables, your summary scores, your duration variables, any additional variables that you create. You want to make sure that they're in the documentation, okay? When I review other programmers' work, the first thing I do is I look through the list of variables, and if it's not on the key form, then I send it, and it's not in the documentation. I say, I have no idea what this variable is, even if I can figure out what it is. I say, you got to provide more detailed description, and I send it back. Okay, let's talk a little bit about summary scores. And I tried to find an example for you this morning. Without the internet, I could not pull it up. But there are often cases where you have questionnaires, as I mentioned earlier, like depression, that measure depression or pain or other behavioral problems. And there'll be a series of 10, 20, 30, sometimes 60 questions. And typically these questions are interrelated and can result in multiple summary scores and typically a total score for that questionnaire as well. And these are very handy because a lot of these questionnaires have been validated and are accepted in the research. And so you go to the literature and you can actually compare your depression scores, your mean and median depression scores for your population with other populations that are published in the literature. And it's actually very handy. And as long as everyone is using the same standardized instrument and scoring the instrument the same way, then these are comparable results. But scoring instruments can be a little bit complicated. So you need to provide a detailed description of how you generated those summary scores. And by doing so, you're actually going to come up with the algorithms yourself and and the procedures for how you're going to actually code it in SAS. So this detailed summary should include the list of variables that were included in the summary scores, which variables were included in which summary scores, and then which variables were recoded and how they were recoded. Quite often, the items will be will have opposite meanings. Like if you strongly agree to one thing, then you are more satisfied. But if on the next question down you strongly agree, that indicates that you're less satisfied with maybe like the service that you're receiving from the clinician or something. So in order to, you can't just add those two scores together, you know, and maybe strongly agree is coded as a 5, because they'll just negate one another. They don't have the same meaning. So you actually have to flip the responses for one of the items so that the higher score still means that you're satisfied with the service that you're receiving. Does that make sense? So that's what I'm getting at here, where you might need to recode. You might need to flip the scoring of specific variables so that they all have the same meaning, so that they're consistent. Does that make sense? Okay. It's not possible to calculate summary scores if you have too much missing data. And a rule of thumb is typically that if 2/3 of the data are not missing, then you can calculate the summary score. Some people say that they need to have 3/4 of the data non-missing before they feel comfortable calculating the summary score. And it also depends on the number of items. I mean, if you've got 50 items going into a summary score, you know, you can live with, you may be able to live with a little more, a higher percentage of missing. If you have 3 items going into a summary score, then, you know, you may not be happy. You may insist that at least 2 of those 3 are there before you're calculating, before you let the score be calculated. In this documentation, you also need to explain how the missing values are addressed. So typically when calculating a total or a sum score, the mean for the other non-missing values can be calculated and imputed for that missing data. Okay? If the summary score is a mean itself, like, you know, you want to calculate the mean score for a set of 5 questions or something, then the missing data can be ignored. Right? So if it's a total, let me just go through that again. If it's a total score, a sum score, you know, like you add all the items together, and you're missing one of the items, then you can't really calculate, you can't ignore the fact that one's missing, because that person would have, you know, would naturally have a lower total, or the potential of a lower total than all the other patients who have complete data. So what you can do is you can take the mean of the other 4 items that are not missing and add that to the other 4 items to come up with a total. So that sort of adjusts for the mean, it adjusts for the missing when you're talking about a total score. But if the summary score is a mean itself, then calculating the mean of the missing value doesn't add anything to the mean, because the 4 items, the 4 non-missing items would have the same mean as if you imputed the mean for the 5th item and then calculated the mean. So it doesn't matter, okay? But it's very important to understand that in both of these cases, whether you're calculating the total or the mean, that you cannot ignore the minimum requirement for non-missing data, okay? So if you have 5 items that go into a score and you say, I have to have 2/3 non-missing, So you have to have at least 3 of the values answered. You can't calculate the score if 4 of them are missing, or even if 3 of them are missing. You can't, whether it's a mean or a total, you cannot successfully calculate that score because too much of the data are missing, and you can't really come up with a valid score for that patient. Okay? So even if the score is a mean and you can ignore the missing, or if you can impute the mean for the missing data in the case where the total is a sum, the summary score is a sum, you still have to pay attention to this minimum non-missing requirement. Okay? And then the final thing that you want to have in your documentation is what's the meaning of the score? And how is it scaled? So you want to include the possible range, how high the score can be, and how a high score differs from a low score. So you want to have something in your documentation to say something like a higher score indicates more depression. Because a lot of times certainly the biostatisticians and possibly the investigators don't know how the instrument is scored. So you want to make sure you say what a score means and what the scale is. Okay, when you create an analysis data set and you're going to distribute it to the statisticians and to the investigators, you want to make sure you include what we call a data set cover sheet. It doesn't have to be exactly like this, but it includes the additional information about the data sets that you're distributing. So what the project name is, and then a lot of this stuff you can get from the original concept proposal. Who the principal investigator is, again, that's typically on the concept proposal. When the original request was made, and you can even attach a copy of the concept proposal. And then the data sets created, the names of the SAS data sets that you created. The name and location of the SAS programs that were used to generate these data sets, that's always nice to have, especially if you have multiple data managers working with in the same project, or you're going to pass on some of your responsibilities to somebody else, and they don't have to go searching for things. All the information will be right here. When those data sets were created, who created those data sets. Some of this is redundant with the stuff that you're putting in your SAS program, but this is what's actually going to be submitted to other people. Okay, the statisticians and investigators are probably not going to see your SAS programs. And then we also just list who the biostatisticians are, so we know who the data went to. And then a description of the cohort, what subjects are included in this data set. And then the description of the derived variables. So this is your documentation. This is where you would put how age at ARV start was calculated and what it means, okay, for example. And then your SAS formats with the proc format statement. And then typically we would do preliminary statistics, just descriptive statistics like frequencies and so we would pick out the most important variables and maybe include them in this document. But that's sort of optional here. If you create additional versions of the data sets, usually I provide an updated version of the cover sheet as well. Okay, so just some general notes when you're using SAS. If the study is longitudinal, you need to provide at least 2 data sets. One that contains the longitudinal data, the data that's collected multiple times, and one that contains just the demographics of the cross-sectional data, the data that you only have one observation per person, okay? Statisticians they know how to merge data sets. So if they need to get the date of birth into that longitudinal data set, they can merge those 2 data sets and make it happen. You don't ever want to put cross-sectional variables such as gender into the longitudinal data set. I sometimes have this argument with statisticians because they want that data in there. And I said, okay, well, if I put gender in the cross-sectional data, in the longitudinal data set, how are you going to calculate frequencies on gender? Oh, well, I'm going to have to manipulate the data set to find just one observation per person and then calculate the frequency on gender. And I said, or I can give you the cross-sectional data set and you can just create you can generate automatically on that data set without any manipulation, you can create frequencies on gender. So, you know, there are trade-offs, but I think it's just cleaner and more concise if you're not mixing longitudinal data with cross-sectional data. And the way you ask yourself this is if you're wondering whether this is a longitudinal variable or cross-sectional variable, you say, well, does this change over time? If I were to have it in a longitudinal data set, would it be different for every observation, or could it be different for every observation? And the answer to things like gender and date of birth is no. Okay, so that's a cross-sectional variable and should be in a separate data set. You want to be careful about formatting your dates. I've made some mistakes where I formatted dates with just a 2-year extension for the years, a 2-digit year, and didn't realize that there were some years in there that were like 1895 instead of 1995. So it's a good idea to always format your dates so that you can see all 4 digits. And when I'm working in East Africa, I almost always use date 9, and I apologize, I did not use that here in these presentations, but I almost always use date 9 because then there's no confusion about if it's month or day first. And then you want to default to the numeric type. Numeric types are just much easier to work with, and the statisticians prefer numeric types over text fields. So when you're distributing a SAS data set, if possible, you want to have another data manager review the data sets and the documentation before distributing. They don't necessarily have to read through every line of your SAS code that created those data sets. But the idea is that they should be able to go to your SAS data sets, open the SAS data sets in SAS View or in SAS, and look at the documentation and be able to understand what the data sets are for, what all the variables mean. Maybe they also need the form keys. But it should make sense to them, okay? And if it doesn't make sense to them, then you probably need to do a little bit more work on documenting, or there may be problems with actually how you generated the data sets or derived the variables. So it's really handy to have somebody else look at your data sets and documentation. When you're distributing data sets, especially to statisticians, you need to include the following. You need to include form keys, the electronic data dictionaries, form keys, whichever you have. You need to include the appropriate data sets, and all these data sets should have the extension SAS7BDAT. You need to include the data cover sheet, which we were just working on. The latest data request form or the concept proposal. It's almost never the same. I mean, the concept proposal is submitted, there's discussions, there's meetings, they tweak the aims, they may change the hypothesis a little bit. So you want to make sure that the final version of that concept proposal is made available to the statisticians and the investigators. And then any other documentation that you need that further explains the data set. In most cases, the following should not be distributed. You do not want to distribute any protected health information. And these include things like the subject's name and address and phone numbers, social security numbers, national ID numbers. The statisticians do not need this information to analyze the data. I mean, they may need GPS coordinates for some sub-studies, but you need to be real careful about distributing those. And even things like date of birth may not be necessary. What I usually do is I usually calculate age for every observation and calculate ages at specific points in time, and I round that age to the nearest tenth. So they don't, a statistician doesn't really necessarily have to have the exact age, and so they don't actually need the date of birth, and especially here in East Africa where a lot of people don't know what their exact date of birth is anyway, you can substitute age for date of birth. You don't need to give your SAS generation programs to the statisticians. At least in my SAS programs, there's a lot of PHI in there. There's a lot of protected health information, things where I'm listing out people's dates of birth and maybe even their names, so I can distinguish men from women, etc. So I don't hardly ever make those those programs available to the statisticians, or certainly not the investigators. So let's just talk a couple minutes about file maintenance and archiving. For your own records, what you should keep is a copy of everything that you give to the biostatistician. Everything that you've ever given out should be stored. I mean, almost everything is electronic now. Should be stored and saved and preserved in an archived subfolder on your hard disk somewhere, okay? Because they'll lose things. They'll come back and say, can you resend that data set? And if you've overwritten it, then you have to say, no, I can't. And you may be in trouble if you can't reproduce the same data set that you had already given them. You want to make sure that you archive a copy of all the logs and the SAS programs, especially those that create permanent SAS data sets, but I would also say anything that creates SAS data sets that you're passing on to somebody else, you should save the log in the program, and even the output file too. It's a good idea to keep copies of the grant proposals, meetings, notes from meetings, the scoring algorithms, instructions, any manuscripts. A lot of times you'll get the scoring algorithms from the published literature, and you should try and keep a copy of that in your folder that's associated with this particular study. And it may be helpful to maintain a subdirectory for each specific study that holds all of these data. And in addition, you may also want to have a subdirectory that mirrors the data entry system. And then this applies mostly to the simpler data entry systems like Access, or if you've actually developed the Access data entry system yourself, then you should keep that separate on your computer, and so that you know so that you have a copy of what the data entry clerks are seeing, or what the data manager is actually using at the site. And then for longitudinal studies in particular, it's really important to archive data sets and SAS programs which were used for analysis and abstracts and papers, because typically in a longitudinal data set, there'll be interim analyses. So you'll actually create analysis data sets midway through the study, and then another data set at the end of the study. So you need to make sure that you preserve each of those in separate files. And then just a few notes about working with investigators and biostatisticians. You want to make sure that you are seen as a team member, okay? I mean, you want to be involved in the decision-making process. You want to contribute, because if somebody goes and designs a data collection form without having input from from a data manager, they're probably not going to do a very good job. And it's going to be really hard to develop a good data capturing and electronic system for that data, for that questionnaire. So you want to kind of make sure that you kind of become part of the team. And that involves attending the study meetings, documenting, taking notes at all the study meetings, Certainly you want to comment on any proposed study changes. I don't think I've ever been involved in a research study where midway through the investigator says, okay, now I want to add this questionnaire, or I want to stop doing this on these group of patients, you know. And you really have to have many discussions about this before you make those kind of decisions, because they can really affect the outcomes of the study. And it's good to get the statisticians involved in those discussions as well, because they may have comments about how it's going to affect the analysis. You want to try and understand the analysis plan. I mean, sometimes it can get very, very, very complicated. But understanding how the statisticians are going to use the data and what variables are most important will really help you focus your attention to those in those areas, and making sure that you've got the data properly formatted to address the questions. I like to review the statistical reports before they actually go to the investigator. So I work in the division of biostatistics, and I work very closely with a lot of statisticians, and we usually form a team on each project. And I like to review the analysis that they do, mostly to make sure that I have conveyed all the information appropriately to them. Because when they start doing the analysis, they don't have the knowledge of the raw data that I have. They may not have been involved in developing the data collection form. They may have never even met the investigator, you know, or know anything about how the study is conducted. So it's really important that, you know, I do the best I can to convey all my knowledge to them, but it's obvious when I'm looking at some of the analyses that they've overlooked something, or they've misinterpreted one of my variables or something. So it's a good idea to meet with them on a regular basis and review their reports. And then I spend a lot of time looking at manuscripts and abstracts. People sort of have come to rely on me to go through with the detail, you know, with a detailed head and comparing every value. Is this the right number? Is this the right mean? Is this the right value, you know, p-value and so forth. So, but also in addition, you can contribute to the narrative, and even to the results section and the description of the study and so forth. So it's good to have the data manager's input to make sure that. And sometimes when I read manuscripts, I realize that I didn't understand things exactly the way they are, and I may need to adjust some of the variables in my data sets. So just remember that your contribution is extremely important in these settings with research data analysis. That's all I have. Any questions? Okay. Thank you very much. I'll be here all week.